We're going to conclude our discussion on Chapter 7's atmospheric circulations by talking about the El Niño Southern Oscillation. Now, remember in our last video, we finished up by talking about ocean currents. We have warm currents dragged east to west near the equator because of the trade winds, and then winds dragged west to east between 30 and 60 degrees latitude because of the westerlies. And as a result, you get a circulation pattern in your ocean currents that is clockwise in nature in the northern hemisphere, like so. We want to focus right here on the west coast of the continent. We'll start off looking at the west coast of North America, and then we'll end up looking at the west coast of South America. There's something interesting that happens here with the California current. If you've ever gone to California and decided to go swimming in the ocean, you've probably noticed that the water gets rather cold. In fact, here is a good temperature contour for the ocean temperatures. We see right here in Northern California, the temperatures are quite cold, just right in that area, and then either direction they get warmer. Why? This has to do with a process called upwelling. It has to do with something called the Ekman spiral. What happens is as you have the prevailing wind, you have the Pacific high sits off the coast and creates a prevailing wind going clockwise around a high, so north to south over the summer. Now in the winter, this high pressure moves away, and so this isn't as prevalent in the winter. But in the summer, this prevailing wind gets so strong that it drags the water with it. Now, coming back here, we talk about the Ekman spiral. The Ekman spiral basically says that if water is dragged north to south at the surface, then down in the water a little ways, that water is then dragged outward, 90 degrees to the right, so in this case to the west. That's the Ekman spiral. Point is, because of the wind pulling, dragging north to south, it pulls some of that water away from the coastline and drags it out to sea. Well, if you drag a bit of water out to sea, then the water near the coast is replaced with water from the bottom of the ocean. So this is called upwelling, where the water that's dragged away is replaced by cold, nutrient-rich water from the bottom of the ocean. The same thing happens near the Peruvian coast. Let me come back here. There we are. We have the Peru-Humboldt current, which does the same thing in this area here right next to Peru. You get a bunch of upwelling that occurs near Peru. So here we've got North America, Central America, South America, here's Peru. So you get upwelling that occurs near Peru. And so if you took that latitude all the way across the Pacific, you'd see you have a cold, dry situation here with your Pacific high centered right near Peru. But then on the opposite side of the Pacific, you have a low pressure system which brings rising air, very wet conditions on the other side of the Pacific. Okay, so you end up with this, once more, a thermal circulation of sorts. Okay, this is actually pretty normal, and Peru's economy thrives on this. This upwelling, again, I mentioned earlier, it brings up the cold, nutrient-rich water from the bottom of the ocean. That brings a lot of nutrients. It helps replenish the fish. It replenishes the birds who thrive on that, on those fish. Agriculture uses the water from the ocean, and it brings a lot of good nutrients for the agriculture. Everything is great. But every once in a while, that upwelling stops and the pattern actually reverses. You end up having downwelling near Peru and upwelling on the west side of the Pacific. So the whole situation reverses. Well, what does this do? Well, now your nutrient-rich water stays lower, and so you're left with warm water. Fish don't thrive as well. In fact, fish die out quite rapidly. Birds die out. Agriculture isn't as good. There are a lot of things that can happen during this warming period. Now, this is a regular pattern that actually happens on a yearly scale, on a yearly basis. It actually happens right at the end of the year, last couple weeks of December, first couple weeks of January. That's generally when it happens. Now, Peru being a solidly Latin-based religious country, anytime they have events like this, they name it after some Christian event that happens in that time period. Well, what Christian event happens in the last couple weeks of December? Christmas, where we celebrate the birth of Jesus Christ. And so they named this yearly warming after the person who they celebrated at the time, the child, which in Spanish would be El Niño, which is why we give it that name, El Niño. All right, so when it does occur every year, it lasts for a few weeks, just a warm period where agriculture's kind of down, just a dip in their economy there, just for a few weeks, nothing big. But every once in a while, this El Niño lasts for multiple months. And what we've noticed is that when you have these long-lasting major El Niño events, then it has large effects on weather globally. It has large effects on agriculture globally, and it has large effects on global economy as well. And so oscillating back and forth between these upwelling and downwelling periods, just keeps going back and forth and back and forth, we call that a southern oscillation. The southern oscillation is the periodic reversal of surface pressures between the East and West Pacific. Generally, we're talking about on a large scale. This actually tends to happen every couple of years. For about a year and a half, you get an El Niño, a large-scale El Niño event, and then for a couple of years, you have a non-El Niño, a couple of non-El Niño years, and then a couple of El Niño years, and a couple of non-El Niño years. And so it's a southern oscillation that goes back and forth periodically every couple of years. And so this relationship between the El Niño and the southern oscillation, we often just use the acronym ENSO, El Niño Southern Oscillation. Let's look and see where we actually stand right now in our El Niño Southern Oscillation period. We're coming down here on our weather page. This figure here shows actual sea surface temperatures. Now, the sea surface temperatures themselves aren't necessarily what's important, but whether we're warmer or cooler than normal. And that is this figure right here. We want to look at anomalies. So what we see here is that in general, a little bit it's cooler, but for the most part, we're brownish color. Brownish color means that we are generally positive temperatures above normal, means we're warmer than normal. So technically, following this, we may very well be in an El Niño type of situation. Now, an El Niño is best indicated with a corresponding cooling in the Western Pacific, which we don't really see very well right now. So if we are in an El Niño situation right now, it's not a very strong one. So. All right, now perhaps you've heard of the opposite of El Niño, which is La Niña. Remember, El Niño is when the waters near Peru are warmer than normal. But every once in a while, when it reverses in the southern oscillation back to a normal condition, occasionally temperatures will actually get to be colder than normal. This is what we call La Nina. El Nino is when the temperatures are warmer than normal. La Nina is when they're colder than normal. Usually they just oscillate between El Nino and normal conditions. El Nino and normal conditions. But every once in a while, the reversal gets a little more drastic and we end up colder than normal. Okay, so how does this affect our weather globally? Well, honestly, we're not exactly sure what the connection is, but we are sure that there is a connection. For example, here's something we've seen over North America. During El Nino conditions, you end up with a really strong subtropical jet stream coming across northern Mexico and the southern United States. Brings wet, cool air into our region. But in the north, you have very warm, dry air because of the polar jet stream pulling the dry air from the north, but it's not very strong, so it leaves very warm and dry conditions in the northern United States. And yet, when that reverses, when we get La Nina conditions, the polar jet stream gets to be much, much stronger, so it brings much colder air from the north. And your subtropical jet stream shifts, bringing wet air also up into the north. And where does that leave us here in the south? Very dry and warmer than normal. There are other oscillations. The El Nino Southern Oscillation is the one that has had the most attention, and it's the one that we are most aware of. But there are a couple of other oscillations worth noting. There's the North Atlantic Oscillation. It's a reversal in pressure in the North Atlantic, which affects weather in Europe as well as the eastern coast of North America. You end up with two phases, the positive phase and the negative phase. And let me just show you the pictures here. On the left, we have our positive phase, where you have a very strong low pressure, which brings very strong winds from the south and pulls it up along this trough. So it brings mild, wet weather up into northern Europe, while southern Europe stays mild and dry. Here in the US, we say mild and wet. But in the negative phase, the low pressure system is weaker, so the pressure rises. As a result, the United States remains colder, and this band of mild, wet air is not pulled northward, but stays across the southern European countries, leaving them mild and wet, and the northern European countries cold and dry. Another oscillation worth noting is the Pacific Decadal Oscillation, a reversal that happens every 10 years, hence why it's called decadal. You have a warm phase and a cool phase. In the warm phase, you get more Pacific storms. In the cool phase, the northwestern North America gets wetter and cooler. So here's the couple of figures. On the left, we have our positive or warm phase. You can see that the northern Pacific is warmer than normal, whereas the western Pacific is colder. And then in the cool or negative phase, all of a sudden the coastlines of North America are cooler than normal, whereas the western Pacific is warmer than normal. This cooler water affects fish life and all sorts of other activities along the western coast. And there are a few examples of different oscillations, the primary being the El Nino Southern Oscillation.